Hey everybody, Mr. Bowman here, another video for us on 3.9 bivariate data, and in this video we're continuing with the regression line theme that we had in the previous video. This time around we're doing another skill using that regression line to make a prediction. So in the video we're going to look at kiwi height again, and you can see the kiwi height stuff there, and we're also going to look at some marathon data as well. So the first step is you got to look at your equation. We've got that down there, and then we've got to have a look at kind of the question we've been asked. So the first question I've got, if a kiwi was 40 centimeters, that will refer to the height. What weight would that kiwi be? So basically what we're going to be doing is looking at the graph, we're going to find 40, we're going to go up to our line, and we know that it's going to be somewhere in this, slightly above 2.5 range. But in bivariate data for level 3 maths, we can't just eyeball it like this. We have to mathematically use that equation to find it. So the thing we do know is we know the height is 40 centimeters. So what we're going to do is we're going to take out the times height from the equation, and we're going to put in times 40 instead. So I'll show you what I mean by that. So the weight of the kiwi that we're trying to predict is going to be equal to the gradient, which from our previous video, we know it's going to be 0.061319. And the model now says times height. We're going to take out the height part, and we're going to put in the 40 that we're interested in. And then back to the equation, we're going to add on, we call this the constant, but we're going to add on the number at the end. So plus 0.11618. So that's quite a messy number. In the internal, you're going to have lots of messy decimals. Don't try to do any maths in your head or by hand. Get your calculator out. Don't risk any silly math errors. So I've just entered in the gradient, and I'm going to go times 40, and I'm going to go plus 0.11618. If I push equals, that means my prediction is going to be 2.56894 kilograms. And that was actually really close to that eyeball prediction we chatted about. We said it was going to be slightly over 2.5. So that kind of confirms what we were looking at, but we are a lot more precise than the eyeball method. So once we've made our prediction, so we've got our working, that's really important. We're then just going to explain in a bit of words, what that actually means. So we're going to start off with based on my regression line. I would predict that a kiwi with a height of 40 centimeters would have a weight of, and we're going to put in our prediction over here, 2.56894 kilograms. So that's our nice. If you're looking to get merit, or maybe you're looking to push beyond it, a nice idea would be after this, you might state, or you might want to talk about how confident you are with that prediction. Like, do you think that's a pretty accurate prediction? Do you think you're going to be unreliable? In this case here, if I was talking about that, at the point that we're looking at, which is 40, you can see the data starts down the bottom here, and it goes all the way up the top, and then basically we've got quite a wide gap. So our one, it could be anywhere between 1.5 and 3.5 kilos. So our prediction, because of the variation at that particular point, I'm not too confident in it. It could be a lot more, it could be a lot less. So that's what I'll be talking about if I wanted to discuss how confident I was with that prediction. So let's have a look at another example, 60 centimeter kiwi. And we're going to be doing the same thing. We're going to be using that formula that we did above, but instead of the 40, we're now going to sub it out. We're going to put in the 60. So our weight in this case will be equal to the gradient, which don't forget is 0.061391. I'm going to go times 60 because that's what I'm looking for this time, and I'm going to add the 0.11618. So key thing to note, The gradient stayed the same for both of these calculations, and so did the constant at the end. The only thing that changed was the number that we were putting in for the height, and that's because the question asked us about a different height. So let's get rid of all those. Now let's talk about what this means. Oh, actually, we haven't even calculated it. So again, it's got some decimals. Don't waste your time doing this in your head. Let's get the calculator out. So 0.016318 times, or 19, sorry, times 60 plus 0.11618. And I'm getting 0 point something. So I've clearly done a mistake. I've done times 60, so let's just times that by 10. There we go. So I'm getting 4.8 kilos. That's quite a lot bigger than my previous prediction. So 4.84094 kilograms. So big Kiwi, and I guess that makes sense because it is a lot bigger. The graph goes up to 52, so it's a lot bigger than all the ones in the graph. So let's talk about what this means. So based on my regression line, I'm going to use the exact same wording. Particularly for these achieved parts, there's no point being creative. Like smarter people than us have got the wording sorted for us. Our job is to do the calculations correctly and thoroughly, and then convert it to the statistical language that we're looking for. So I would predict that a Kiwi with a height of 60 centimeters would have a weight of 4.84094 kilograms, full stop. And again, if you're wanting to push up to merit or excellence, you got to talk about how confident you are. In this case, I would be talking, I'm not very confident because I did something called extrapolation. So it's okay to make a prediction kind of within your data because you can observe that trend and you know what's happening, but I don't know what's happened afterwards. Like, does it start going up? Does it start going down? So I'm not very confident. The trends I've observed, I haven't seen them, what's happening around that 60 mark. So I'm not particularly confident with what I've done here. So our next question, so we did some Kiwi stuff. Let's do one quick question on our marathon data. And this one's real. I actually got a tape measure and I stepped out my stride length. And because I'm quite tall and lanky, my stride length was 180 centimeters long. So Mr. Bowman is a stride length of 180 centimeters long. How long do you think it would take for him to complete a marathon? So we're going to do the same thing. We're going to pull out our equation, but we're going to take out stride length. We're going to put in the number we've got, 180. So in our case, the minutes will be equal to negative 1.8696 times 180. Oh, I missed out a number there, haven't I? 86 there. There we go. And then we're going to go plus 530.33. So again, I've substituted the 180 in for the stride length that I know about. I'm going to grab my calculator out. So we've got negative 1.8696 times 180. I'm being a bit more careful this time so I don't make a mistake. Plus 530.33. My prediction would be 193.802 minutes. So I'm not going to do the full wording for you this time, but like our previous one, you would do a bit of a paragraph about, based on my regression line, I would predict blah, 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 and you would talk about that there. But following this one's maybe a bit more interesting because if you were going to talk about the merit and excellence stuff, about how confident you were, you could maybe talk about the context of it a little bit more. So all these people who've done the marathons here, these are trained marathon runners. And if you've seen me in class, I like my burgers and my pies. I'm clearly not a marathon runner. So it's highly doubtful that I will be doing a marathon run in that time. So the context of the scenario is a little bit different. This is a prediction for marathon runners. It would be unwise to use this information to predict for someone who is not a marathon runner. And that's maybe something you could talk about for your prediction if you are confident or not. So hopefully you found this video useful. We chatted about making predictions. We also talked about confidence and some ideas that we could talk about as well. So thanks so much for watching. Now let's get into some mahi.